Hey everybody, it's Mr. Stoltenberg again. Coming with you next video with the next video for the solutions unit. Probably second to last video we're gonna do, and then we'll be done with solutions. Today we're going to talk about something called concentration, and believe it or not, we'll actually have to use a calculator today. I know, asking you to do math and chemistry is crazy, right? Thought you were going to get through a whole unit without it. But no, today we're going to learn how to calculate concentration, which is pretty much probably the most useful aspect of the solutions unit, is doing molarity calculations. All right, so let's go. Concentration. The concentration of a solution is a measure of the amount of solute in a given amount of solvent or solution. It's a quantitative quality of a solution. It's basically telling you how much of a solute is dissolved in a certain amount of solvent. The term that we use for concentration is called molarity. Molarity. Look at that beginning of that word. Guess what molarity is going to have in it? That's right, it's going to have moles. Molarity is the number of moles of solute in 1 liter of solution. So moles of solute per liter. We use a capital M to represent molarity. It has to be a capital M. Lowercase m represents meters, right? It's the amount of solute in moles per liters. That's the unit. Moles per liters. And that's really all you need to solve for molarity. If you have the number of moles, if you have a number of liters, divide the number of moles by the number of liters. That gives you molarity. Of course, it won't always be that simple, right? I don't always give you moles, and I don't always give you liters. So sometimes these calculations will require you to do some converting. If you're talking about molarity, the molarity of a solution, it's said in a certain way that sometimes people find confusing. It's just the way the vocabulary works, just the way it's said. So, in class before we've used acids or we've used other solutions, and you may have seen this written on the side of the bottle at some point. 6 with a capital M, or 0.1 or 1.25 capital M, and then the symbol for the formula for the whatever compound that solution is composed of. And you've probably heard me say this before, but now you're officially going to learn it. So when you see a label like this, the way we say that is that we say it's 6 molar HCl. 6 molar HCl. So if this was like 1 M, whoa, look at that M, that's a really good one. That would be 1 molar. Or if this was 0.25, this would be 0.25 molar, whatever these solutions might be. That's how we say it. So, if in the past, anytime we've done a lab, we've done a particular solution, when I'm telling you something is molar, I'm telling you the concentration of that solution. I'm telling you the molarity. So 6 molar is essentially 6 moles of HCl for every 1 liter of solution. Again, molarity is always moles per liter. All right, so it says it's probably the most important unit of concentration. It is the only unit of concentration that we use, so yeah, it's definitely the most important. Knowing the correct technique for preparing a solution, Probably not going to go over that right now. We'll wait till we have a lab and we can use that lab as our teaching tool for how to prepare a solution. But if we need to, we'll come back to this. But for right now, we're going to skip on to doing actual calculations using molarity. All right, so here's your example problems. I'm going to switch camera to live camera, and we'll work some of these out together. So let's do this. Go over to our desktop cam. All right, so here are our practice problems. Same as yours, I just printed it out so I have a little more space to work with. So when we're doing molarity calculations, you're basically going to have two types. There's going to be, well, technically there's going to be three types, but we won't get into the third type till next video. Um, Today there's only two types. There's questions that will specifically ask you to just calculate the molarity, and those are pretty straightforward. Just calculate the molarity given the information that you're given. And then there's questions that give you the molarity somewhere in the question itself, and the method that we use to solve those is a little bit different. So we'll start with simple, and we'll get a little more complicated. So in these first three, all we're doing is calculating the molarity. Well, all you really have to remember is that molarity is just the number of moles over the number of liters. That's all you need. So if you have moles and you have liters, that's it. So let's read this question. It says calculate the molarity of 0.06 moles of NaHCO3, so sodium bicarbonate. So I have 0.060 moles. Now I just need the volume. It says in 1500 milliliters of solution. 1500 milliliters. Can I put milliliters down here? That's right, I can't put milliliters down there because it has to be liters. Now, if you're, used to this doing milliliters to liters, you're just dividing by 1,000, or you're just moving that decimal over 3 times to the left. However you want to do it is up to you. You could even do this if you wanted to. Write 1,500 milliliters down here, even though we know we don't want milliliters. So if I don't want a unit, I just use train tracks to get rid of it. So milliliters is on the bottom, so milliliters goes on top, liters goes on the bottom, and we know that 1 liter is 1,000 milliliters. So in this case, what we would do is 0.60 times 1,000 divided by 1,500. Milliliters would be gone, and we're left with moles per liter. Again,
Paris, at this time you will report to the same station that you were at yesterday. This morning, just report to the same station you were at yesterday and listen for an announcement for changes.
again, if you want to change this to 1.5 liters and just do that, that's fine. You don't have to show this. I just like showing the math and showing you how it would work if you wanted to plug it into the train tracks. So you would end up with, let's see, moving that over 3 times, 1, 2, 3, 60 over 1,500. Let me double check my math here. 0.06 times 1,000. Yeah. So 60 over 1,500 gives us 0.04 molar. And that's NaHCO3. So this is our final answer. 0.04 0.4 molar sodium bicarbonate. Pretty straightforward. Moles divided by liters. But like I said, I'm not always going to give you moles and liters. Sometimes I'll give you grams. Potassium permanganate here. Potassium permanganate. Oh no. We're going to have to remember what permanganate is, aren't we? MnO4, but what's the charge? Permanganate would be -1. So potassium permanganate would be K M N. Oh, come on. Get it together, Stoltenberg. There you go. KMnO4. All right, so this time we're calculating the molarity of a solution prepared by dissolving 11.85 grams of potassium permanganate in enough water to make 750 milliliters of solution. So we have grams of potassium permanganate and 750 milliliters of solution. All right, so we know we have to have moles per liter, right? So what does that tell us we have to do to these grams? You guessed it, we have to convert. So we're going to take that 11.85 grams of KMnO4 and what I could do already is go ahead and put the volume down here. I know 750 milliliters is 0.75 liters. So all I need to do is convert these grams to moles. Grams is here, so I know grams goes down here. What do we use to go from grams to moles? That's right, we use molar mass. Remember, molar mass is always per 1 mole. So let's see, KMnO4. Of course, I can't remember what manganese is. So let me take a quick look. We'll call it 55. Call potassium 39 and oxygen 16. So 55 for manganese plus 39 for potassium plus 16 times 4 for oxygen. 16 times 4, 64. So I get 158 grams per mole. And I'm rounding pretty significantly here. You probably don't want to round quite this much, but it'll be fine for a practice problem. So multiply across the top, multiply across the bottom, then divide. So we have 11.85 on top. 0.75 times 158 on bottom gives us 118.5. Huh. Those numbers look very similar. So 11.85 divided by 118.5, and we get 0.1 molar KMnO4. So we take the grams, we convert it to moles. Moles divided by liters gives us 11.85. Divided by 118.5 gives us 1.1 molar. Now, if you wanted to do this in 2 steps, you could. If you wanted to not do the division in here and convert it to moles first, and then do moles divided by liters, that's fine. I mean, it's same mathematical process. You're just doing it in 2 steps instead of doing it in one conversion problem. It's not. You don't necessarily have to do this. Put the volume in here as well. Just makes it a little more simple in my opinion. All right, let's look at the next one. Let's calculate the molarity of 34.2 grams of sugar. Looks like sucrose in 500 milliliters of solution. All right, so what I want you to do is, if you're watching this live or you're watching this, pause. Obviously, you're watching it. Pause it right here. See if you can't work this out, and then play it, and I'll work it out and see if you're right. Okay? So So pause and try to work this out on your own. All right. So again, solving for molarity, moles per liters. I have grams and milliliters, so very similar to the previous problem. I'm going to have to convert grams to moles and milliliters to liters. So I'm starting with 34.2 grams of C12H22O11. And my volume is 500 milliliters or 0.5 liters. All right, so we got to get those grams and turn them into moles. So grams will be down here. We're going to use the molar mass of this compound, C12H22O11. It's going to have a decent mass, right? So carbon is 12, so 12 times 12 is 144. Plus 22 from the hydrogens, one each, right? Plus 11 times 16 for the oxygens. And I get 342 grams per mole. Okay, again, all I'm doing is looking up the individual masses of these elements, multiplying by the quantity, and then adding it all up. Just calculating molar mass, something you should be able to do at this point. All right, so now we just do the math. We end up with 34.2 on top. 0.5 times 342, so half of 342, 171 on bottom. So 34.2 divided by 171 gives us 0.2 molar C12H22O11. There you go. Pretty simple. Again, this is the first type of question where it's simply going to ask you to calculate the molarity. And all you need is moles per liters. All right, on the back is the second type of question, and these are slightly more complicated. But if you know how to solve them, if you know how to do the math, then they're actually pretty simple. The questions are going to seem difficult, but it's actually pretty simple. All right, so in these types of questions, instead of asking you to calculate molarity, what the question will ask you to do is it'll give you the molarity of some solution and then ask you some question about it, like how many liters you would need of water you would need, or how many grams of this solution you would need, or how many you can make. Basically, it's telling you what the molarity is and then asking you a question about that molarity. So in this one, number 4, it says calculate the number of moles of NaCl contained in 0.5 liters of a 1.5 molar solution. So basically what they're saying is you have a 1.5 molar solution and that you have half a liter of it. So how many moles would have to be in that half a liter to give you a molarity of 1.5? Well, this is where you need to, if you realize what molarity is, it actually makes this pretty simple. Remember, molarity, again, is moles per liter, right? Moles per liter. One unit per another unit. This is written like a fraction, right? But in this class, what have we called this? This is called something. Starts with an R. Yeah, man, y'all guys are getting so smart. Yeah, y'all are right. It's called a ratio. This is molarity is a ratio. If you remember that, then it makes these problems really, really simple, because if you have a ratio and you want to maintain that ratio, then all you have to do is set it equal to a second fraction. And that's what we're going to do here. We're going to take our ratio that was being given, and we're going to set it equal to a second fraction. Well, 1.5 molar. Well, what is that ratio? It's very simple. It's 1.5 moles over 1 liter. This 1.5 molar is this. 1.5 moles divided by 1 liter. This is what 1.5 molar is telling you. It's this ratio. 1.5 moles for every 1 liter. Well, in this question, do we have 1 liter volume? No, we don't. We actually have half a liter of volume. And it wants to know the number of moles in that half a liter. Well, we know what the ratio should be, so all we have to do is set it equal to a second ratio, set it equal to a second fraction, where our volume has changed. It's not 1 liter, it's now 0.5 liters, and we're solving for how many moles. So what we're doing here is we're saying we want this ratio, but with this volume. So how many moles would that require? But once we get it like this, it should be pretty simple, right? This looks familiar. We solve problems that look like this in the gas laws unit. This is two fractions set equal to each other, so we use the butterfly method. Cross, multiply, and divide. So I'm going to cross multiply here, cross multiply here. I'm going to write it over here because I've kind of run out of room, but I normally would write down x times 1. Well, that's pretty simple. That gives us x. 1.5 times 5.5 is 0.75 moles. And that's our final answer. So, again, to maintain this ratio of 1.5 moles per liter in a volume of half a liter, we would need 0.75 moles. So I'm sure you probably don't need to, but if you wanted to, 0.75 divided by 0.5, you want to punch that into your calculator, and I bet you get 1.5. All right, let's look at the next one. This one says calculate the mass of NaCl needed to prepare 175 milliliters of a 0.5 molar saline solution. All right, so here's our given molarity. So I'm going to write that as a fraction. 0.5 molar is 0.5 moles over 1 liter. Now I'm going to solve, set it equal to a second fraction. I'm going to solve for what? What am I solving for here? Well, it says calculate the mass. Well, mass would indicate what unit? That's right, it indicates grams. So can I directly solve for what this question is asking for here? And the answer is no. But I can solve for moles. And if I know the number of moles, I can figure out the number of grams. So I'm going to solve for moles again, but in this one, my volume isn't 1 liter. My volume is 175 milliliters, or 0.175 liters. All right, so we cross multiply and divide. We end up with 1x again, so x is equal to 0.5 times 1.175. So 0.5 times 0.175, you get 0.0875 moles. All right, so common mistake here is to put a box around this and move on to the next question. But this is where you have to just pay attention to what the question is actually asking for. I don't want moles, I want grams. So I'm not done. I have to take these moles and turn them into grams. But we've done this so many times now that surely it's not a question. We're going to take moles, convert it into grams using molar mass. So 1 mole down here, molar mass NaCl, see sodium's 23, chlorine's 35.5, so we'll call it 58.5 grams. Moles would cancel. All we have to do is multiply 0.0875 times 58.5. Gives us a final answer of 5.12 grams NaCl. So this question was worded a little different. It made it seem a little bit more difficult than it was, but ultimately in the end, it's nothing really new for y'all. Cross, multiply, and divide is a calculation we've done before. You know how to do. Converting moles to grams is a calculation we've done, hundreds of times at this point. So it's just understanding what you have to do to solve this problem that makes it somewhat difficult. All right. So again, in this one, I want you to pause the video, try to work out question number 6, and then when you're done or you think you have the answer, let the video play and you can see if you're right. So go ahead and pause now, and then we'll come back and see what we got. All right. So number 6 here. It says calculate the volume in milliliters. Calculate volume in milliliters. So we're solving for volume, and ultimately we want that answer in milliliters. So we got to make sure we remember that. It says needed to prepare a 2.48 molar sodium hydroxide solution. So 2.48 molar sodium hydroxide. So that's my first fraction. That's my ratio. So I know my ratio is 2.48 moles per 1 liter. I know that's the ratio that I want established. Okay? So we set it equal to a second fraction. Okay, it says the solution containing 31.52 grams of the solid. All right, well, this is posing a little bit of an issue here because we need moles over liters, right? Well, we already know we're calculating volume, so our X is going to be down here. But what goes here? Moles, right? It has to be number of moles. What am I given? I'm given grams. So in this problem, guess what we have to do first? That's right. You guessed it right again. Wow, good guessers. We got to convert these grams to moles first, then plug it in here. So we're going to do train tracks first in this one. 31.52 grams of sodium hydroxide, which I'm sure you all figured out is NaOH. And we're going to convert it to moles of NaOH. Sodium hydroxide is a pretty common chemical, so I kind of remember that it's always 40 grams per mole. So use the molar mass of sodium hydroxide to convert these grams to moles. So 31.52 divided by 40. I'll go ahead and use that whole number, 0.788 moles. So this is the number of moles we're working with. So we can take this and plug it in up here, 0.788. Cross multiply and divide. Then this time we'll have to divide. 2.48x is equal to 1 times that is 0.788. Divide both sides by 2.48. x is equal to, so 0.788 divided by 2.48 gives me 0.318 liters, which if we want to turn this into milliliters, we times by 1,000 or just move that decimal three times to the right. So our final answer, 318 milliliters. There you go. There's molarity. Two types of problems. One where you're just calculating molarity, so knowing this, all you need is moles over liters, so moles divided by liters. Sometimes you'll be given grams, sometimes you'll be given milliliters, so just make sure if you're given one or the other, you're converting it always moles over liters. Very simple. Second type of problem will be questions where you're actually given a molarity and you're asked some sort of question about that solution. Well, in those problems, you have to remember that molarity is simply a ratio and that we want to maintain that ratio in whatever parameters they give us for the question. So we take this molarity, convert it into a ratio. So 1.5 molar becomes 1.5 moles over 1 liter, set it equal to a second fraction, where we're either going to be solving for the number of moles or the volume, just depending on what the question gives us. In this case, we're solving for moles, cross multiply and divide. Just keep in mind, I can ask these questions, of quite a few different ways. I can give you, different units and whatnot, but in the end, it's basically the same thing. You're going to use that molarity, set it up as two fractions equal to each other, do any converting that needs to be done, but the math itself is relatively simple. All right, that's it for this one. We should have one more video in this unit talking about the last type of calculation we're going to do. And that'll be it. All right. Thanks, guys. See you soon.